Today's daily Leetcode question is a hard problem, number 726, number of atoms. Uh, Given a string formula representing a chemical formula, return the count of each atom. The atomic element always starts with an uppercase character, then 0 or more characters representing the name. One or more digits representing that element's count may follow if the count is greater than 1. If the count is 1, no digits will follow. For example, H2O and H2O2 are possible, but H1O2 is impossible. Two formulas are concatenated together to produce another formula. For example, H2O2 He3Mg4 is also a formula. A formula placed in parentheses and a count optionally added is also a formula. For example, H2O2 and H2O2 are formulas. Return the count of all elements as a string in the following form. The first name in sorted order, followed by its count if the count is more than 1, followed by the second name in sorted order, followed by its count if the count is more than 1, and so on. The test cases are generated so that all the values in the output fit in a 32-bit integer. Okay. So for example, H2O, we just output H2O. Yeah, and then MgOH2, you output H2MgO2. And then this, okay. And the formula length is less than or equal to 1000. So we can actually just run like an n-squared algorithm here, but I don't think that's too necessary. Formula consists of English letters, digits, and the parentheses, and the formula is also always valid. Alright, I think this problem is also kind of straightforward. It really just depends on the implementation, which can get kind of annoying, I think. So let's look at this example. I think one important case that these examples don't cover is like having two parentheses inside another parentheses like this. So it's not just all nested, it could also expand laterally as well. So let's say, I don't know, NA, NABR2. It's been a while since I've taken chemistry, but yeah, okay. Okay, so I think the easiest way to do this is to use a stack. We can have like, okay, so each time we put on a parentheses, we add something to the stack, right? And then when we remove a parentheses, we remove the topmost element from the stack. That way we can keep track of the parentheses, which one's opening, which one's closing. So here, I actually think it's probably easiest to have a stack of counters. Okay. Yeah, stack of counters. And then for each element, we withhold from adding it to the counter until we fully parsed it and find like the quantity as well. Okay, I low-key don't like string processing, but here we go. I'm gonna do stack is equal to this, and we can just initially put in a counter. And then we can have I for the current index is equal to 0, because I think we don't want to use a for loop for the index here, because we want to be able to we want to be able to increment the index how we want it to, because we're not just going up by 1 every time, we're going up by like the whole element. So while I is less than length of formula, Okay, so first we have to find like the element. We can do end is equal to I. Do while and hold on. We can do while and okay, wait, no. End is going to be equal to I plus 1 because okay, you know what? Let's first test if the character at I is a parentheses, because if it is a parentheses, then we don't have to do all this. So we do if string I, or let's do if string I is not a parentheses first. Okay, you know what? No, let's do if it's a parentheses. If it's a start parentheses, we just add a new counter, stack.append counter, and then I plus equals to 1. Elif string I is equal to a end parentheses. We can first find the count of the end parentheses. I wonder what, I don't know what like the technical term here is, but I'll just name it digits. No, that sounds stupid. Counts, count, count. Okay, count is equal to no, we don't need that. Okay, I plus equals 1, so we move it past. Okay, while I doesn't equal end is equal to I, while end doesn't equal to no, while end is greater than equal to 1 and end is less than 9, or I guess it would be 0, right? It would be less than equal to 0 plus equals 1. Okay, so if it's just a parentheses and there's no number like immediately after it, so for example like this, what should happen is I is going to start equaling this, and then end is also going to start here and it's going to immediately stop. So we can do or count is equal to, so if end is equal to I, that means count is equal to 1, right? Or yeah, end is equal to I, else we can just do int of string starting at I and ending at end. I'll rename this mult for multiplier, because I guess that's more akin to what it's actually doing. So now we have counts is equal to stack.pop counter Because if it's an end parentheses, we know there's more than one counter in there. Okay, yeah. All right. And then we can do stack -1 plus equals mult times counts. Because I'm pretty sure Python counters can be manipulated this way. And also, even if we have something like this, where everything's inside the parentheses and such, this would still work. Because we would have like a base counter that would be empty, and then we would immediately stack on another counter. So then when we pop that last counter, we still have a counter to fall back on. So there is always going to be a counter, like 2 counters at least on the stack when this happens. So yeah, so Okay, this looks good to me. Else, this should mean it's a capital character. So we can just do end is equal to I plus 1 while end doesn't, while end is greater than or equal to A and end is less than or equal to Z. So n keeps going as long as there's a lowercase. As long as it's lowercase. Oh no, I'm thinking about this wrong. It should be string end. Because end is still just an index. So while this happens, and increments up, so at the end we have that the element should equal to string I to end. Yeah. And then now we have to find like the multiplier or like the counts for it. So this should just be I is equal to end and then we just copy the code from up there. String end is greater equal to 0 and string end is less than equal to 9. And plus equals 1. I guess here would be more appropriate to name it counts. Or, yeah, I'll just name it mult again just for the consistency. So mult is equal to 1 if end is equal to I, else int end. So we can do a stack -1 element plus equals mult. Okay, that should do the trick. Oh, we also have to make I go up. Here, I should equal to end. And also here, I should equal to end. Okay. Now we can just have answer is equal to nothing for element in sorted stack 0. Oh, I guess for these it would still be better to do like the join thing. So we can just do this. Answer dot append element if stack 0 element is greater than 1. Then we do answer dot append the string of stack 0 element, and then return dot join answer. Okay, this code's pretty complicated, so if this runs first try, I'll be pretty good, which I'm not. Bro, are you serious? I've been using string the whole time, but it's actually formula. Oh, it's because I was working with this other problem that had a argument name string, so that messed me up. Wow, this is annoying. Formula. Alright. Please, Leetcode gods. What? I guess I have to bounds check for everything. I forgot about that. Dang. Bro. Are you serious? Counter object cannot be interpreted as an integer. Oh, what am I doing? You just pop it, you don't need anything in it. Holy crap. Can you not multiply counters like this? I swear to God, I thought you could do this. Dang, actually? Okay, I know you can add counters together, right? Okay, I guess you can. I'll just like manually do them. So for Okay, now I'm not too sure about the efficiency of all this. At least it works. It works, it works. That's all that really matters. Let's give my little concoction a shot with a lateral expansion. Am I feeling it? Bro, I don't know if this is gonna time out or not, honestly. It shouldn't though, because it's only 1000. The longest it could be is 1000. Yeah, honestly, this like multiplication stuff is also kind of linear time. It should work. Come on. Let's go! Too good at this. I want to check the complexity real quick. Yay, it's linear time. Very helpful. All right, let's see what the goats are doing here. Yeah, looks like they're doing pretty much the same thing. So long though. Can't they just use counter? Whoa, this guy has a reject solution, a regex. That's crazy. No Lee 215 solution. Unlucky. Well, I think like my solution is relatively simple compared to theirs, I think. Look how long these are. Oh, this is Java though. So they're using like string builder and stuff. Uh-oh. Shortest solution. Uh-oh. Nah, it's like the same thing as mine. Oh, okay. They're checking every character right to left. I thought about this because it would make it easier. Because I wouldn't have to go through and remultiply everything. I could just go in with the knowledge of what I have to multiply each element by. Like I can have like a factor already on hand, but I don't know. I think this solution is already pretty straightforward, so I just did it this way. Okay. Well, I guess all the solutions are pretty similar in the end. Yeah. So two hard problems in a row for daily Leetcode questions. That's pretty interesting. Maybe we'll have a third one tomorrow. End the just completely end the Leetcode hard problem drought. But yeah, both of these hard problems have been pretty straightforward though. So hopefully we get something cool next time, like an interesting monotonic stack problem or like DP or something like that. But yeah, hopefully again these videos help you. And as always, I will see you guys tomorrow. Bye bye.